Oh, I didn't see you there. Welcome in Vienna. What a wonderful day. Tomorrow is Friday, and you know what it means? Tomorrow is WorkerConf online. It's the first time I see this online. I'm going to be there as well. And there's going to be one special guest, Sean Grove. For those people who don't know Sean Grove, it's an old colleague of mine, so I know him pretty well. He's the founder of OneGraph.io. It's a platform to connect all the different SaaS services like Zendesk, GitHub, Twitter, like all the platforms you usually use in your business, and connect them all together in one single GraphQL endpoint, which is pretty mind-blowing when you think about it. So he's going to have a talk at WorkerConf about next generation API clients and owning your abstractions. He knows a lot about gluing data together. And he also knows a lot about GraphQL and product development. So I am really looking forward to Sean's talk. Check it out and see you at WorkerConf. See ya.
I'm going to be talking about next generation API clients for integrations and how you can move much more quickly in your projects with them and still maintain your own abstractions. So a quick aside about me, my name's Sean, coming out of San Francisco. In a previous life, I ran engineering for a payments company where we built and maintained hundreds and hundreds of integrations. That led me to join my current company where we deal with integrations on a massive scale. But I won't really talk about that specifically today, other than some experimental work we're doing, trying to reify and make concrete some of the best practices. Other than that, I have a background in a lot of developer tooling. Good DX, good UX is kind of near and dear to my heart. So I'll be taking a deep look into integrations today, in particular the steps of building them, debugging them, maintaining them, some of the challenges that come along the way, and some of the best practices that can be extracted so that you can build kind of a integrations as a service, if you will. And we'll also be taking a look at some of the experimental demos around these best practices that we've been working on. So for the purposes of today, the integration we're going to be working on is adding an enriched GitHub signup flow. So in this scenario, we already have an email flow that a user can sign up with, where they'll fill out email and password, fill out some personal information and some company information. So about 3 steps that the user takes. We want to offer an alternative flow where they can sign up with GitHub. We'll take that email, we'll then enrich it via Clearbit so that the total steps required for a user to move data is 1. To set the scene, let's take a look at how I think this integration could be done in the ideal scenario, kind of using some of those experimental practices that we'll talk about. And then we'll break that down and compare and contrast it with how things are normally done. So over on the left, I can see the pre-built blocks, either by me or by other people that have been shared. Some of them will just be individual actions. Some of them might be a collection of actions. But I can click on them and just see exactly their inputs and their outputs. But in this case, because the chain is so short, I'll go ahead and just create it from scratch. And this first query is going to go ahead and go into GitHub and get the current user's emails. So I can see over here the catalog of all the available APIs, and I can kind of drill into the part that I care about. So I'm going to go into GitHub and viewer, which is the currently logged in user. I see email, but also a special field, which is a privileged email field. So if this is the currently logged in user, then go ahead and grab the email, is primary, and is verified. So I see exactly the data that's going to be coming back here. And I can get an immediate preview of the structure. So these are objects. This is an array of objects, booleans and strings. Let me go ahead and just execute this. And you can see that I'm already logged in. So it came back with a list of emails. So that's the first one done. Now let's go ahead and make a second block. And this one is going to use the Clearbit API, which has an enriching functionality, but it's going to take an email as a variable. And based off of that, it's going to reach into the company of this particular person, get their domain, we'll get maybe their location, their name, and their logo. So again, I can see the inputs and the exact output. So now I'd like the data from the GitHub user email to flow into the enrich email. And I'm getting an error immediately because it's telling me that this enrich email requires an email input. So we can go ahead and start computing that. So let's drag in some data from this. We'll get a list of all of the emails. And instead of just the first one, we'll use all of them. And now maybe we want to go ahead and say email is going to be this value dot find. And I want to return whether this is both the primary and if it is verified. And so if we get that, And you can see that this is coming back already. And this actually doesn't look quite right because I just want the actual email. If I were to return, for example, email here and email, I would get an error saying that, hey, I expected a string and you gave me this kind of structure. So I'll go ahead and just come back here, and if we have some value, I'll grab the email. Similarly, if we don't have an email, I will just return early. And let's make that pretty. So there we go. I was able to add my custom transformation logic and visualize it inside of here and know exactly the data that's coming back. All right, with that demo in mind, let's go ahead and compare and contrast that to the way that things are done right now. Where in the lifecycle of integration, the first step is typically to read the API documentation. And the thing is, by the time you read the API documentation, the product has probably already sold you. It said, I can do X, Y, and Z, and you thought, oh, great, I need to do X and a little bit of Y. So you come into the documentation with some use cases already in mind. The thing is, where you start with the documentation may be very, very distant from actually figuring out how to achieve your use case. And fundamentally, every API has three capabilities that it offers. So the first is going to be read. It might have some data that you care about. The second would be write, where it can perform some sort of function, maybe storing some data, creating a payment, sending an email or an SMS message, or it can notify you of some change that has happened in the world so that you can react to the things that you care about. So it can kind of align a API along these different axes of read, write, and listen. And if you're familiar with GraphQL, this should seem pretty familiar because these directly map to query, mutate, and subscribe. Now, whenever we first enter into the documentation, we have a use case in mind. Maybe it's a little bit in the upper right of this graph. And the documentation is this blue here, where it's describing the capabilities of the API and saying, hey, we have some queries over here that you can get out once, or you can subscribe to changes, and some read and writes that you can do over here. But our use case isn't necessarily close to all of those. So we're probably going to have to work our way through it. And this is the worst with documentation that simply enumerates capabilities and says, hey, I have all of these endpoints. And then it's up to me as the reader to figure out, well, is this endpoint relevant to the use case I'm trying to pull off or not? Of course, a lot of them are going to have better organizational stories. They will have maybe objects and say, hey, we have a payment object, and here are all the things you can do that are related to payment objects. And this is nicer because it gives you a sort of gradient vector where you can work your way through the documentation and tell, am I getting closer to my use case or am I getting further away? And use that to course correct and kind of hone in more quickly on how to achieve your use case. Unfortunately, very few API docs actually have extensive examples. Where you say, hey, if you want to do X, this is as close as possible as we can get you to it. And that's unfortunate because examples are effectively bookmarks into this space where I can take a quick look at an example, determine whether or not this is close to what I want, and then jump to the next one. So I can kind of quickly jump through the space, and once I find one that is sufficiently close, I can go ahead and then maybe take that and tweak it to get to my use case. So the first challenge in building an integration is that exploration is typically somewhat difficult. Depending on where you start in the documentation or with your integration and figuring out the path to get to your actual use case. And what might be nice as an alternative, kind of what, as we saw in the demo, is if we could capture the source API, where we say, here are all of the bits of data that are available inside of the API, all their types, whether they're nullable, etc. And then we could use that as the source of truth, both for the data as well as for the effects and for the events that we could listen to. And GraphQL obviously does this pretty heavily. But this is not a new idea. OpenAPI is hugely adopted, and it's also not a new idea by any means. This goes back a few decades at least with SOAP. And then we have some more recent additions to the family, like Async API. But effectively, all of these are trying to capture information about the source API so that we can rely on it in a confident manner. And so what we could do is maybe capture all of the APIs upstream that we rely on and put them inside of a catalog as our source of truth. And by capturing the source of truth and the effects, we know all the data that's available, along with the types, with close to 100% confidence. Anything that isn't known ahead of time is clearly marked out as some sort of maybe JSON blob, which calls out danger in a really nice way. It says, hey, this area is particularly dynamic. You'll have to be careful with your code. So let's take a look at what it's like to actually explore an API using this catalog-based approach. And the first thing this chain is going to do is we're going to subscribe to Salesforce. And inside of Salesforce, we just want to know whenever an opportunity has been created. And whenever it's created, we'll go ahead and pull out the amount. We'll pull out its ID, whether it's been closed and won, the name, as well as the stage name. Okay, we've explored an API, and now it's time to actually write some code and make some API calls. And just as a reminder, we are trying to enrich a GitHub user who is signed in, get their verified email, and then go enrich that and get some information about their company. So having read through the documentation on GitHub, I find the endpoint that has the data that I care about, and I'm going to go ahead and just simply fetch that. It's not a big deal. I will await the response. And in this case, I'm cheating a little bit. I'm making an assumption that the JSON is an array, not an object. But maybe GitHub stocks are pretty good. So then I go through and I iterate through the addresses, trying to find one that has been verified, and I pull the email off of that. If I got an email successfully, then I'll go ahead and pass that into Clearbit, and I'll get back my enriched information. Along the way, you can believe that I am going to be console.logging a lot, because documentation is one thing, and then the actual shape of the data that we get back is oftentimes another. And it turns out in this case that I didn't realize that there was maybe a primary field, which is a Boolean. So what I'll do is go back to my code that I wrote previously, and I'll modify the assumption so that I'm not just pulling out the verified email address, I actually want the one that is the primary verified email address. And this highlights a secondary challenge, which is that confirming our expectations can be quite difficult because those expectations are scattered throughout the call sites of the client code. I didn't know that there was a primary, or I didn't know that it was an array instead of an object. And then there's a lot of code that relies on that in a way where the expectations are not made explicit. So it's really nice if you can actually extract that so that you have your expectations in terms of inputs, outputs, and transformations all bundled together. And then those inputs and outputs should largely be based off of the API catalog. So in this case, we're going to say, well, I have a specific named action, which is I want to enrich a new user who signed in via GitHub. Given their GitHub user ID, I want to reach into the API catalog for a query that will give me all of the GitHub user emails. And then I'm going to run a little bit of logic on that to extract the verified primary email. In this case, it's JavaScript, but you could imagine if this was a service internal to your company, you might have it all written in Ruby or C#, whatever it might be. But then you're going to take the result of that and then reference the catalog once again, pull out the enrich email with Clearbit function, and then you'll get some company information out. And this is nice because now we have taken that action, which is multiple steps and transformation logic, and we've kind of bundled up into its own little standalone package. And so we've captured the source from the API catalog, all of the functions that we're going to be referencing. We've captured the input requirements and the output requirements. And we can also do this during development. And this will allow us to actually explore and iterate on our integration bit by bit, and then we can visualize the output instantly. So let's take a look at what it's like to actually visualize and iterate on the data during development. Real data flows through here now. And so once again, if we come in here and we pull our picker in, you can see that we're no longer seeing the preview of mock data, we're seeing real data. So if I want to pull out maybe the name here, you see that that gets assigned in here just as we'd expect. Similarly, this is also really nice whenever you're playing with the individual forms. So maybe I want to try out this block and I need a track ID. I can actually just drag from this block and say I want to pull this ID here. And this works for all sorts of values. Okay, we've worked our way through the API documentation. We've built something that seems solid. And now it comes time to actually deploy this to our different clients. But there is a challenge there, which is we might have more than one client. We might have JavaScript, or we might want to allow someone to sign up via GitHub on the iOS app or on the Android app or the desktop app. There are lots of scenarios where we might want to reuse this specifically crafted action. And the challenge here is that the logic for that action is deeply tied to our implementation, which includes both the language and the runtime. So even inside of JavaScript, maybe the transformation logic is relying on some node crypto library that isn't available in the browser. And so that means that each of these clients effectively has to go in and re-implement that transformation logic and deal with testing and exploration kind of all on their own. Whereas if we have this action defined and we have a separate service where we are locating all of these, we can basically take this well-defined input and output and say, well, we know enough about this and how to make these calls on these different platforms. Let's generate a really high fidelity package that can be used from Dino or from TypeScript or Swift or even Ruby. Whatever the endpoint is, you can say, look, we have defined our actions that are available for our whole team in one place. Here's all the documentation, here are all the types, here's the package that you can use. And this kind of centralizes everything, including definitions and logic into its own service. And that service can now rely on the API catalog as the source of truth. So you can generate all those nice idiomatic safe bindings. Those packages make it much, much easier to use from something like Swift, which wants to have significantly more type safety than maybe some of the other options. And this also means that one action is now shared and reusable across multiple platforms. And you don't have to worry about maybe the iOS team didn't implement it quite the same as the React Native or the JavaScript team. And so some of the users who signed up via the iOS app have very different company data than they would have had they signed up via the JavaScript app. And this also means that because we have named integrations, which are these series of steps, we can actually track metrics. How often are they being called? Are they expensive? Are they slow? How are they affecting our user experience? You can enforce usage limits and say, well, it seems like this client is calling into this specific series of actions a bit too much. We should go ahead and throttle that. And if the time comes when you need to upgrade and maybe add some new higher fidelity metrics to your apps, you can track down all of the different clients. Just keep track of who's calling it in and have them send in a user agent string. And now you know, oh, someone's using our older package. So let's take a look at the experience of actually publishing a package of a collection of actions and then consuming it inside of something like TypeScript inside of VS Code. I'm going to go ahead and publish these changes to npm. And give it my API key. That'll go out and create a new package. It's published now. And we see that our package is published. I'll go ahead and copy this and install it inside of my project. And now inside of my project, I can go ahead and import everything from my package. So now I should get full autocomplete. I see all of the chains inside of my package are listed here, along with full TypeScript support. You can see that I get nice autocomplete. And it's nice also that my doc string comes through. So it's a nice little human level of documentation. I'll go ahead and enrich Daniel here. And I see that this is a promise, so I'll go ahead and await that. And now whenever I ask what's on my enriched object, you can see here that I have the GitHub email as well as the clearbit block. And I can go ahead and get the data, and maybe I'll get the clearbit. And let's go ahead and pull out the company logo. So this is effectively go into this user's GitHub, grab their email, and then let me know what the logo of the company they work at is. All right, so we've published this. We're consuming it from lots of different platforms. The next step is basically we really hope that we caught all of the edge cases and based off of the input that we tested with. But this is very, very rarely the case, and almost inevitably something will go wrong, and then you need to debug. But debugging API integrations is particularly difficult. Rebuilding the sequence of events of what happened effectively goes something like you check the logs, hopefully you have some logs, you find some calls to one API, you find some calls to another API. It's not always clear that they were related. Maybe there are lots of them that are interleaved, maybe there are some that are happening simultaneously. Trying to figure out the linear step of sequence of events so that you can debug what actually went wrong based off of the logs oftentimes takes quite a bit of work. And then once you have finished that reconstruction of what actually happened, you need to figure out what expectations did you have about the data and the transformation that you were doing that wasn't actually matched by reality? Maybe it's nullable fields, or you weren't authorized to get the user's email. Or maybe you were authorized, but you didn't realize that emails could take on a certain shape, like they have a plus in them, which is absolutely valid, and every service should allow users to sign up with a plus in the email. So there are lots of expectations that you might have that are actually not mirrored by reality, and you didn't trigger them during your cases that you were testing with. And reproducing this is typically a nightmare, because the data that flowed through your system at the time that you were making the API call might not have been logged. The provider certainly doesn't remember the time that you called it. And so you do this kind of partial best effort reconstruction based off of the logs of what the state was and inputs and outputs. And what this generally looks like is that you didn't log enough. And so you push some more logs to production and you wait to see it again, and you hope that you've caught enough. And maybe you didn't, and you do this again and again and again until you have captured enough of the inputs and outputs required to reproduce enough of the problem so that you know what your expectation mismatches were. So this is the third challenge, which is that debugging the exceptions in this case can be particularly difficult, especially depending on the nature of the API that you're dealing with. Whereas if we have these named actions, what we can do is actually attach some kind of metadata to them, where I can say, this enrich GitHub user action, I want to attach a data storage policy. I want every time it's called, I want to capture all of the inputs and all of the outputs from every API call. Or maybe I only want to do that whenever there's an error, store it in memory, but if there's an error that happens, go ahead and commit it somewhere. But only store that for 25 days. And also, this may have personally identifying information, which is affected by the GDPR. So we need to make sure that we're storing this in a safe way. And so we can take all of these concerns and simply attach them to this action, and then push all of that down into the system to make sure that it's being handled by a specialized system so we don't have to worry about it. And then from then on, our clients are just simply calling them and getting this really nice idiomatic experience. And all of the back and forth between the actual APIs is happening in this integration as a service. Any sort of slow API calls or error traces can be stored. They can be managed appropriately for HIPAA or GDPR. And so we have these nice instant repro cases. We can instantly capture all of the results, which means we have instantaneous reproduction. So any surprising inputs or outputs, we can capture, we can debug, and we can actually save for future tests. And because we're working at this much more clearly defined level of make this API call for this specific intent, do these transformations, and each step has a name, it's very easy to tie together a story of saying this step happened, and associate the API calls with the code that's actually operating off of it. So let's take a look at what trace-based development actually looks like with automatic reproductions. And I look at my enriched GitHub, I can actually see a list of traces. So these are all the times that it has been called before. And so here we see it was called with Daniel's input. We see the resolved email, as well as the enriched data here. We also see all of the previous calls to the actual APIs. So if we want to see the raw API calls, we can actually see them, as well as some overall information here. If, however, I come in here and I go ahead and run this with saw, whenever I come back to our trace, I see that there's actually an error here. And this is really nice because even though I called this from inside of my JavaScript code here, I can have a full trace of exactly what happened, including what went wrong. So whenever I look at the clear bit, I can see that the value for this email was actually empty. So let's go ahead and come in here, and I'm going to use this as a mock. And I want to know maybe what's going on exactly. So I'm going to change email to go ahead and be a computed value. And now whenever I drag in the email here, I can say, let me get the email as well as the bio and the login. And I can see that for this particular trace, even though it was called from my JavaScript, I can actually see what's exactly going on here, where they have a login, but their bio and their email are both empty. So what I'd like to do is make it so that by default, the email is going to be equal to the email here. However, if the email is trimmed and equal to that, or if the email is null, then I simply want to return early and I don't want to run this. So that way there'll be no error, even though we won't get any enriched data back. And so I can see here that this is true and this is not being evaluated. So now if I come in here and I try this again with SAW, we can see that the GitHub email runs just as we expect, but the clear bit was never executed because we terminated early here. All right, so we've pushed this out, we've debugged it. At some point, we're going to have to upgrade the integration. And there are two kinds of upgrades that can happen upstream, one of which is an additive change, which is no big deal, right? Old clients ignore it and new clients opt into it. Breaking changes are much more difficult, especially in that fetch-based world where we just have URLs as strings that we're hitting. In particular, we have to find all of the usages of that broken API, the one that is now being removed. We have to communicate what the breakage actually was, and then update the expectation of all of the code around it. And this means that over the long term, maintaining up-to-date clients is really difficult. YouTube moved from V2 to V3 of their API, deprecated V2, and anyone who was on that had to rewrite their integrations to get to V3. Every single client had to be updated in order to get access to the same data that they were getting previously. And that can be really difficult to make sure that you have found all of the references. That can be nerve-wracking. Whereas if we have this much more named approach where we have an explicit action that we're trying to make available to our clients, let's say, for example, Clearbit no longer offers the company information whenever we're enriching a client's email. Well, what we can do is say, well, there's another company that does do that. And I can take those traces from before that we had. And because I know the shape of the data that's expected to be returned, I can go in here and I can use this other company's API and plug that same data in. And I can then push that out to our integration as a service. And all of our existing packages just continue to work. So we're able to swap this out in one place rather than in different places, including some older clients that we maybe can't update anymore. Maybe they're iOS clients that have been running for 5 years. And this leads me to one other possibility that I'm pretty excited about, where the kind of current cycle that we've talked about is, we build an action, we document it, and then we track the results. But going back to our initial documentation question, I would ask, who is the best at example-driven API documentation? And I would argue that it's Stack Overflow. Stack Overflow is this crazy community-driven site where people say, I'm trying to do X, and other people come in and say, well, here's how I would achieve X. And it's hugely successful, as we all probably know. So I would ask, why aren't integrations more like Stack Overflow meets NPM? Why can't I just post a question and get one of these reusable bits back? And part of it is because of, like we talked beforehand, implementation is locked into one language. If the answer is in PHP and I'm writing in Ruby, I have to kind of translate it over, including finding the right libraries or packages or rewrite the encryption, whatever it might be, in a way that makes it quite difficult. And even if it's in the same language and I copy and paste it, it kind of melts into my code. And if I were to change it a little bit to fit the last mile, those tweaks are not pushed back to the Stack Overflow. At best, maybe you're a good citizen and you go and you comment or you add a new answer. But a high percentage of people, more than 99%, are unlikely to go and do that. But in our case, we don't have that problem because we have explicitly defined the interfaces for our integrations, as well as made the logic kind of standalone. We don't have to worry about that. So we can build an action, document its usage, track the results, and then share it with other people. Just like we saw in that initial demo, I had a list of blocks and actions that other people had built. And so I can say, hey, is there an example that includes this keyword in its description or references this field or uses this function? If so, let me take a look at it and see if it does what I want it to do. And if it does, then great. I can just bring that in and use that in any of my clients. And maybe I tweak it for the last mile again. Or I change it to handle some new edge case that wasn't there before. And then I can push that up so everyone else can benefit. And this is because we've captured the intent of the action. We have the individual steps and we know what is an API call to make a change, what is to get data, what is the transformation of it. We have the ability to optimize it better. We can share our enhancements to it. So it's almost as if Stack Overflow had importable examples. And of course, we can use this both internally within our team, but I'm really excited about being able to do this across the entire internet, the entire community, so that an API provider can say, hey, here are dozens and dozens or even hundreds of examples of how to use our API. maybe search through there and just go ahead and import that into your code and you're up and running. One last point I want to touch on is the ability to stay in your own domain. Because we've wrapped up these actions into atomic shareable units, it means that we get to control their interfaces. We know their inputs and their outputs. And this gives us the ability to actually hide implementation details and data that we don't care about or that our team doesn't care about. In particular, maybe there's an API call to create a Zendesk ticket, and all your company teams care about is providing a subject and a body. That's it. But the Zendesk API requires you to fill out lots and lots of other fields. Well, you can capture the part that you actually care about inside of a create ticket action. And you can implement all of the implementation details that you care about or that Zendesk cares about there, and not have those concerns infect the iOS client or the JavaScript client. And this is already what you would typically do. This is an API team inside of your company who says, well, we have other teams who need to interact with this external API. We'll put together our abstraction, our common language for dealing with it. To give you an example that I live in is pushing files to GitHub. In the ideal model for me, I know that I have a GitHub repository and a branch and some files. And I want an API call where I can just push these files to the repository. It'll create the branch if it doesn't exist, and the files get there. That's it. In my mind, that's a very simple concept. The actual implementation, if you bring in the entire provider's domain, is quite intense. This is not even everything. This is a lot of work, including computing the Git hash and including a null byte at the end in order to match the provider's domain, because GitHub does a great job of modeling the Git API underneath the hood. But that involves things like nodes and refs and heads and things that I'm not thinking of. I'm thinking of a repository and files. And so to visualize this is what that actual action looks like here, where you can see it's quite intricate. There's lots of input, lots of computation that happens along the way. But after we have modeled it in our domain, we can see that we get a nice package with autocomplete, with typed inputs, where we simply say, here's the name of the repository, the owner, and some tree files. And that's it. We get to stay in our domain. That's a huge win. So wrapping up, what are the goals of our integration? We just want to build faster. We want to move with confidence. We want to be able to debug with real data and not imaginary data. And we really want to minimize the future maintenance whenever there's some upstream changes. And we want to be able to stay in our domain and worry about our problems rather than our provider's problems. And the challenges here are effectively that exploration is going to be difficult. Confirming that our expectations are correct is difficult. Debugging is difficult. Maintaining up-to-date clients is difficult. But part of the way that we reconcile that is by extracting all these implicit pieces and saying, look, here are the components of integrations. We have an API catalog that is 100% or as close to 100% true as we can get it. Based off of that, we have built these individual actions with some little bit of glue logic so that we can say for our company or for our project, these are the verbs that we care about. We can then publish those to all the different clients. They can consume it from there. And we have a centralized place to monitor the ingress and egress of data, the client usage, reproduction, like all of that stuff can be centralized in a really, really nice way. And the thing is, this one client works for all APIs. So an API provider simply provides their catalog, and that's the source of truth. That's their job to keep that correct. But everything else automatically works. You plug that into one side of the machine, and all of the other stuff just magically works. And this means that it is vastly less work for the API provider, as well as for the consumer. Not everyone has to build their own super high fidelity API client for every single platform. It's just simply, here's the data. Your tool can consume it, and you can transform that, map it into the actual bits that your team cares about. And you get to maintain your abstractions, which is nice. So SaaS is really powerful, and APIs are wonderful. We're able to farm out a lot of these different concerns. But integrations with them are still very costly, both to build and to maintain. I personally have spent a lot of time building, debugging, maintaining integrations, and I am pretty sure that users have seen errors that were directly the result of me overlooking some assumptions. And I think that with something like this approach, where it's much more explicit, we have named components, we have confidence every step along the way, and immediate reproductions, we could actually achieve something like a 99% reduction in both the time and errors. So the experiment that I'm working on is not ready for widespread use, but I'd love to get some early feedback. So if you're interested, please hit me up. My email is in the talk. It's sean@onegraph.com. And that's it. Thank you.